In the last video, we talked about lists and tuples and the different kinds of functions that we can use with them. In this video, we are going to talk about for and while loops and the different use cases for them and how we can use them to execute parts of our code multiple times. When writing code for beginners, it's sometimes confusing to know when to use a for loop and when to use a while loop. And we can pretty much boil this down to whether or not we know how many times we want to execute code or not. In Python, there are two types of for loops, but if we know exactly how many times we want to execute a block of code, then we would use a for loop. For the first kind of for loop that we'll look at, this is similar to a for each loop that you might have seen in other programming languages if you're familiar with them. But essentially what it allows us to do is it allows us to grab an item from a list and use it or modify it in some way. For example, if I make a list here called names, and I'm going to fill this with strings, and I'll say John, Sally, and Bob. So this is our list of names here. And if I want to go ahead and get each individual name programmatically, what we could do is we could index them. But let's say that we don't necessarily know how many people or items are in this list, or maybe the list is going to change over time, so it's not necessarily a good way to do this. Well, we can use a for loop and we can actually extract each name from this names list. So the syntax for this is going to be for, and then whatever we want to grab out of it. So in my case, I'm going to name this name, and this is just a variable name or an alias that we set for this item that we take out. So I'm going to say for name in names, and names is the list or tuple or whatever that I have here. And then just like a typical block of Python code, I'm going to add my colon here, and then I can do whatever I want in here. So let's say that I want to just print the name. Well, I can do that. I can go ahead and print the name, and if I execute this code, you will see that I have every name printed out. So John, Sally, and Bob here. And it just essentially took every item in this list and extracted it and then allowed me to do something with that name. Sometimes you might hear this being called a for each loop, or in Python a for in loop, because of this for variable in list, or iterable in our case. Sometimes in Python and documentation you might hear the word iterable, and essentially what an iterable is something that you can iterate through. So in this case, we are taking this for loop and we are iterating through the names list. Strings are also considered iterables, as well as lists, tuples, and dictionaries. We'll get more into dictionaries later, and there will be an entire video dedicated to dictionaries and how to loop through them and the different cases that we can use them for. Also, a slight note that I'd like to make, I updated my linter for Python, so that's why you're getting some of these blue squiggly lines here in my screen. These are just suggestions. There's obviously no errors in my code because it executed, so just try and ignore them. Going back to the for loop, we can also do some sort of comparison or computation to this list. So let's say that I want to get every single name that starts with a J out of this list. And just for that, I will add another name here. I'll just say Jack. And I will have a new list here that says, I'll call this J names, and this will symbolize the names that start with J. So I already have my for loop where I'm iterating through this list of names here. And one thing that I can do is I can actually say, well, let's make a variable called first letter, and let's set that equal to name at index 0. And the reason why I'm doing this is because we know that name is a string, and you can even see if I hover over it, it knows that name is a string here. I'm indexing it at 0 because that's how we get the first name. And then let's say if I wanted to extract these names and add them to this new list, if their name starts with a J, then I would just test to see if the first letter is a J. So how I would do that is I would say if first letter is equal to J, and just for ease of use, I'm going to force this to upper because maybe someone entered their name in with a lowercase, and it's just good practice to get into handling cases like that. So I'm going to say if the first letter in uppercase is equal to a J, then I want to actually add it to the J names list, and I can just add the name in here. And then at the end, if I go ahead and print J names, let's go ahead and see what this has to say. Go ahead and execute this, and you'll see that I do get John and Jack. If I wanted to go ahead and say that this was for S names, then I would go ahead and maybe just make a new list here called S names, and then I would have an elif first letter dot upper is equal to S. Then I would do the same thing. S names dot append first, or I would append the name here, and then I could also print the S names, and the result will be exactly what you think. We have a list with John and Jack and a list with Sally in it. So I went ahead and commented out the code from before, and I'll go ahead and separate it here. And we'll go ahead and take a look at this second kind of for loop, the indexed for loop. The syntax for the indexed for loop is almost identical to the syntax for the for each loop, with just some minor changes. Let's say that I want to print the numbers 1 to 5. I can actually use what's called a range object that is an iterable that we can use a for loop to iterate through. So a pretty common convention that you will see with for loops, especially indexed for loops, is the letter I being used as the item. This is pretty standard across all programming languages, so if you look at other languages or other code, you'll see this. So I can go ahead and say for I in, and then if I wanted to print the numbers from 1 to 5, then I can use this object called a range, and this is a class. You can even see here that the information for this class pops up in this window on my linter here. But let's say in my case I want to do something 5 times, then I will do for I in range of 5. And we'll go ahead and talk a little bit more about this range object in a second. But let's go ahead and just print I and see what happens. Well, instead of printing 1 through 5, it actually prints 0 to 4, and this is because there are some settings that we can pass through to this range object. The first item is the number that we want to start with. So if we wanted to do 1 to 5, then let's go ahead and print it and see what happens. Well, we only get 1 to 4, and that's because of a similar thing that we saw before, in that this is not inclusive, it is exclusive. So if we want to do 5, then we really have to type in 6 here, or you could do 5 plus 1 for readability, but in the end, you do get 1 through 5. There's also another argument that we can pass, and this is the step that we wanted, so something similar to the slicing of strings or lists. Let's say that we want to do every other item. Go ahead and run the code, and you'll see we get 1 through 5. So it's very similar to slicing strings or lists. We can also simulate a for each loop with an indexed for loop, and we can actually do this by combining the range object with the length function. So if I go ahead and uncomment out my names list at the top here, and instead of doing something for 5 times every other time, we can actually go ahead and say, well, I want to do something for the length of this list, and since lists are indexed at 0 starting, then we don't actually have to specify any begin number because 0 is implied. So if I wanted to say for I in the range of the length of the names list, this will essentially say that we want to start at the beginning index of this list and go to the end index of this list. And if I print I here and I run it, you'll see it is 0, 1, 2, 3, and that's because there are 4 items in this list. And if we start the indexing at 0, you have 0, 1, 2, 3. So that's pretty cool, but what if I wanted to print the item at that index? Well, it's fairly easy, and it just involves some list indexing. I would just take the names list and then I would just pass it the index at I. And if I ran that, then you see that we would get the exact same result as just doing for name in names and then printing out the name. If I just wanted to print something out that is not dependent on the index, so if I wanted to print out something 4 times, and maybe I just wanted to print out hello world, so I could say just in here hello world, and I just wanted that to print out 4 times, and I run this, then I do get it for 4 times. But a common convention in Python specifically is if we are doing an indexed for loop, but we're not necessarily using the I variable or whatever you name this in it, we can actually just replace it with an underscore, and you can see that my syntax highlighted it red, and that's basically just letting us, the reader or the program, know that we really have no intention in using this I variable, and we're really just using it as a placeholder for this range object. So if I go ahead and run this, it is identical. This is a little more conventional Python code, but if you were to do for I in whatever, that is also completely fine. We can also combine this indexed for loop with a for each loop by using this function called enumerate. And what this does is it actually allows us to use the index and the item in a list or an iterable at the same time. That might sound a little confusing at first, but it'll make more sense with an example here. So I can actually first just say, rather than range here, I want to use the enumerate function on our names. And it's actually not a function, it's an object because it is an iterable. And you can see that it returns an enumerate object here. And the order of which this object returns is the index and then the item here. So if I wanted to go ahead and print out I and then name, just separating with a comma here so I get that space and I run it, you'll see that I actually get this pair of index and item. This can be useful if you want to compute something to do with the index it is in the list, but also do something with the item itself. There are a lot of different use cases for this, and I encourage you to practice this on your own because the use is there. I'm going to go ahead and remove everything but this names list here, and I'm going to talk about multidimensional lists. What a multidimensional list is essentially a list or multiple lists inside of one list. So if I go ahead and I make a matrix variable here, I'm just naming it matrix, and I'm going to go ahead and remove these items in this list, and I'll go ahead and say that I want to have some sort of matrix. I want to make it a 3 by 3. Now, how I would do that is I have to encapsulate all of it within a list. And then if I wanted to have something inside of here, then I could just do maybe 1, 2, 3, and then the next item is another list, and this is 4, 5, 6, and then one last list here of 7, 8, and 9. We have our 2-dimensional list here, and the reason why it's 2-dimensional is because there is a list inside of a major list here. It would be 3-dimensional if there was another list inside of this. So if I highlight that and do that, this is 3-dimensional. And if you're reading code, you can see this because of the amount of opening brackets in the beginning. I'm going to go ahead and remove this and go back to our 2-dimensional. And just for readability, I'm going to go ahead and separate this out here onto multiple lines. So you can see that we do in fact have some sort of 3 by 3 right here. If I wanted to go ahead and print this out, well, I could use a for loop for it. So if I wanted to say for row in matrix, and then I could do for num in row. So what I'm doing here is I'm actually using nested for loops. And this first for loop here is to actually go through this list and extract these rows. So once I have this list here, this row, then I go through with another for loop and I go inside of this row here or this list and I extract out one of these numbers here. And that's what this num variable that I've set is. So I can go ahead and print out this num. And if I go ahead and run this code, you'll see that I do get 1 through 9 because of the setup that I just explained. Similarly, we can do this with an indexed for loop. It's a little less readable, but there are some conventions and practice that you can use for this. So first, I'm going to actually do what we did before using the range and the length. So I'm going to first do for row and range of length of the matrix. And I'm going to change this to I just because that's the convention that I like. Now, you'll see that we no longer have access to this row variable. So I'm going to go through the range of the length of the matrix at index I. And I'm going to change this num here rather than being num. I'm going to change it to J, and this is also a pretty standard convention. Your top level for loop will usually have an I, and then the one under it inside its child will be J. You'll also see that across other programming languages, but like I said, you don't have to do this. It's just a habit that I've gotten into. So if I wanted to print out this, then I would actually print out the matrix at index I. And then if I wanted to get the item inside of it, I have to put more square brackets next to it and then J. And this just says get the index at I here, and then inside of that I want you to get the index at J, or the item at J, and then I run this and I get the exact same result. I know that I kind of blew through that multi-dimensional list, so I encourage you to practice that on your own. Try using 3-dimensional lists, and we will also practice that in the practice problem if you would like to do that. Moving on from for loops, we now have our second kind of loop that Python provides us, and this is called a while loop. And the use case for a while loop essentially is that we actually don't know how many times that we want this loop to execute. So when we did for loops, we either iterated through a list or a tuple or something, and we did know how many times that was going to execute because it obviously stopped execution at the end of that list. Or if we used a range object, then we knew how many times we were going to do this. But while loops are different in the sense that the loop only continues while a condition is met. So what do I mean by this? So if I wanted to sort of simulate an indexed for loop with a while loop, I will use the keyword while. And actually, before I do this, I'm just going to set a variable equal to 0 here. And I'm going to say while I is less than 10. And then I can go ahead and print I. And so what this code says is that this loop is always going to execute if this condition is met. So basically, if I is less than 10, then the loop will continue. So if I go ahead and run this, let's see what happens. Well, it actually is an infinite loop of zeros, and that's because we have to do the work ourselves, and I'm still scrolling here. You can see that that's what happened. We have to do the work ourselves to make sure that we increment this I variable to ensure that we don't have an infinite loop. So we already know the increment operator, I plus equals 1, and then if I go ahead and run this, and I'll scroll down back to the bottom here, you'll see that we do get 0 through 9 here. If I went ahead and set this to 1, I would get 1 through 9. But if I did want it to be 10, then I would add the equal sign. Another note I would like to add is with the font that I'm using, JetBrains Mono, I have ligatures installed, which essentially means that I get these cool looking icons here when I do something. So just note that that is the equivalent to the less than sign and the equal sign combined. So if I say that while I is less than or equal to 10, and then I print I and increment it, then you'll see that I actually get 1 through 10 here. Well, let's talk about 2 more keywords that we have with any kind of loop, and these keywords are called break and continue. The break keyword is a little more self-explanatory. It essentially just means to exit the loop or to break out of the loop. If I go ahead and say, maybe I want this loop to exit once I is 5. So I can say if I is equal to 5, then I just want to break out of the loop. And then I'll make sure that I increment it here at the end. And if I go ahead and run this, you see I only get 1 to 4. And the reason why it didn't stop at 5 is because of the place that I incremented I at. So keep that in mind. But if I wanted to go ahead and print this first and then run this, then you'll see that I do get 1 through 5. And it's just all down to where I print I out and then where I do the check to see. The reason why it didn't get to 5 is because it broke out of the loop before it even hit the print statement. We also have another keyword here called continue, and this one is a little more complicated than break. It essentially means that rather than breaking out of the loop, I want you to go back up to the top of the loop where the condition is. So what do I mean by that? Well, let's say I had some code down here that I did not want to execute if it was a certain case. So maybe I will set I equal to 0 up top here, and then I'm going to get rid of this. And let's go ahead and remove this break here, and I'll set it to continue. And then I will print I, and then I'll go ahead and move this increment up here. So this is going to change the logic of our code, but let's go ahead and see what our code does. Well, you can see that I get 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. And the reason why I'm getting 10, 11 is because I never actually removed that equal sign here. So if I went ahead and run that again, I would get 1, 2, 3, 4, 6, 7, 8, 9. So why is it doing this? Essentially, what I told my code to do was to skip everything if I is 5. So I could have done something down here. I could have done anything, really. I could have kept that as 5, and then in this if statement, I could have instead substituted it with hello world. And then if I go ahead and run this, then you'll see in place of 5, I get this hello world printed out. So basically what I did was I said, okay, I don't want you to execute this print statement here if I is 5. And what continue does is it says as soon as the interpreter sees continue, it is going to skip the rest of the loop and jump back up here to the condition and then re-execute down the loop. Well, we incremented I after it was 5 to make it 6, and because this was not satisfied and I was 6, it did not equal 5, then we did the normal execution of the loop and we actually just printed out I. I know continue is a little weird and this was not a very practical example, but we will cover all of these in the practice problem. In this video, we talked about for loops and while loops and how we can use them to execute parts of our code multiple times, depending on whether or not we actually know how many times we want it to execute. In the next video of this series, we are going to finally take a look at functions and how we can use them to help modularize our code.